And the next function is inverse cosecant. So cosecant inverse. F of x equals cosecant inverse of x. The question is to find the derivative. Again, I will use notation y. Y equals cosecant inverse of x. Find the derivative of y. And in order for cosecant inverse of x to work, that means x equals cosecant of y. And this is the same as 1 over sine of y. And in order for this to work, so since sine of y is always between -1 and 1, and this is the inverse, so that means x must be either less or equal -1 or greater or equal 1. So this is the domain of this function. So x is less or equal -1 or greater or equal 1. And now we need to find the derivative of this function. So how do we find this? So we treat the function of inverse cosecant as the function given implicitly by this equation. So we treat f of x or y equals inverse cosecant of x as a function given implicitly by this equation. X equals cosecant inverse of y. X equals cosecant of y. And now to find derivative of the function y, we will use the regular method typically used for implicitly given functions. And this method is left-hand side derivative equals right-hand side derivative. Applied to this equation. Now, for this equation, the left-hand side of the equation is just x. So the derivative of x is 1. So left-hand side is x. So the derivative of the left-hand side is just 1. Right-hand side is cosecant of y. And the derivative of that, to find the derivative of cosecant of y, since y is a function, then the derivative of this should be calculated normal way, but then multiplied times y prime. So right-hand side derivative is the derivative of the cosecant, and the derivative of cosecant is negative cosecant times cotangent. So it will be negative cosecant of y times cotangent of y times y prime. We need to multiply times y prime. So now we have left-hand side derivative, which is 1, times right-hand side equals right-hand side derivative, which is all of this. So we have 1 equals all of this, negative cosecant of y times cotangent of y and times y prime. Now from here it's easy to isolate y prime, we just need to divide 1 over negative cosecant times cotangent, so it's a negative 1 over cosecant of y times cotangent of y. Now this formula is good as a formula for implicitly given derivative of explicitly given function. However, in this context we want to express our derivative as a function of x only. And x, since y equals inverse cosecant of x, so x equals cosecant of y. So this is already x. But now we still need to express this portion cotangent of y as a formula involving x. So we need to express the entire formula as a formula with x, but this portion is already x, so we need to express cotangent of y as a formula with x. But what is x? X equals cosecant of y. So we need to express cotangent of y as the formula with cosecant of y, and then we will replace cosecant of y with x. So how to do this? We will start with the main trigonometric identity, sine squared plus cosine squared equals 1, we apply it to y. So sine squared of y plus cosine squared of y equals 1. Now we need to express cotangent as a formula involving cosecant. Cotangent is cosine divided by sine. Cosecant is 1 divided by sine. So we need to divide all four parts of this formula by sine squared. Of y. Sine squared of y. And so what do we have? We have 1 plus cotangent. So 1 plus, okay, this is 1, sine squared y over sine squared of y is 1. Cosine squared over sine squared is cotangent squared of y equals, and 1 over sine is cosecant squared of y. So we got 1 plus cotangent squared equals cosecant squared. So this is precisely what we actually need to express cotangent. So from here we can isolate cotangent. Cotangent squared of y equals cosecant squared of y minus 1. And since we need cotangent alone without square, so we need to do square root. Cotangent of y equals square root of cosecant squared of y minus 1. And this is what we need because cosecant of y is x, so what we get is square root of x squared minus 1. Actually, it could be negative square root as well, but we assume that y has such values that cotangent is always positive, and so this square root will be always positive. And so we have y squared equals negative 1 over. Here cosecant y is replaced with x because cosecant y equals x, then times cotangent y is replaced with the square root of x squared minus 1. So square root of x squared minus 1. And this is the formula for the derivative. Altogether we got that if the function equals cosecant squared, cosecant inverse cosecant of x, then the derivative of this function is negative 1 over x times square root x squared minus 1. So this is the derivative of inverse cosecant.